Find vector x determined by the given coordinate vector and basis. So let's get started here by recalling that the coordinates of a vector x relative to a basis b is, or we should say, are the scalars c sub 1 all the way up to c sub n, such that vector x is defined as a linear combination c sub 1 times vector b sub 1 plus all the way up to c sub n times vector b sub n, and this is where the set of these vectors b sub 1 all the way to b sub n are the bases. Right, and so this is our definition for the coordinates of a vector x relative to a basis b. And so in order to find vector x, so here we want to find a vector x in R3, we're going to need to substitute the vectors b sub 1 through b sub 3 given above. I think these are the vectors of our basis b, and the coordinates of vector x relative to b, c sub 1, c sub 2, c sub 3, into the vector equation. Okay, so let's go ahead and do that. So again, looking at what's given here, we have vector b sub 1, vector b sub 2, vector b sub 3, and then we have our scalars here, that's c sub 1, c sub 2, c sub 3. So we can plug this given information into the vector equation to find as vector x is equal to c sub 1 times vector b sub 1 plus c sub 2 times vector b sub 2 plus c sub 3 times vector b sub 3. And so here we go. We have vector x is equal to scalar 2 multiplied by the column vector negative 5 minus 3, 2. Then we have plus scalar 0 multiplied by the column vector 4, 0, negative 2. And last but not least, this is plus a scalar minus 1 multiplied by the column vector 2, negative 5, 1. And so now we're ready for a little vector arithmetic. So this gives us, multiplying 2 through on our vector, we have negative 10 minus 6, 4, plus the 0 vector, plus, we have the scalar multiple of negative 1 times our column vector here, which leaves us with negative 2, positive 5, minus 1. And so adding up our like terms, we have therefore vector x is defined as, so negative 10 plus 0 minus 2 gives us negative 12. We have minus 6 plus 0 plus 5 leaves us with minus 1. And then 4 plus 0 plus negative 1 is 3. And that is our beautiful final answer.